Hello 3D printing friends. Today on the BV3D channel we'll be taking a look at the Creality Ender 3 Pro 3D printer. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hey everybody, welcome back. Today we're taking a look at the Creality Ender 3 Pro 3D printer. Now to begin with, I'll tell you a little bit about the printer itself before I go into what I like and don't like about the printer and where I think it could use some improvement. But the very first thing I need to tell you is that this printer was a Christmas gift to me from my wife. This is not a promotional or review unit. I've been using it for about 4 months now and I've gotten to know it pretty well. So for starters, I want to tell you that out of the 5 printers I have, this is my second favorite printer. My favorite is my Prusa i3 Mark III, but this one is my second favorite. In fact, its print quality can rival that of the Mark III. And it wasn't difficult to put together. The base part of it was pretty much already all together with the electronics and the bed already in place. When you assemble it, you'll put together the parts for the Z tower, and you'll assemble the X arm with the extruder, and then you'll add the power supply and the screen, and you'll plug all those little bits together. If you're bored, you can watch the recorded live stream from when I put it together. Alright, so let's talk a little bit about the printer. The Ender 3 Pro is made by Creality, a 3D printer manufacturing company based in China. They've been around for about 5 years, and in fact, they just celebrated their 5th anniversary this month. They make a range of 3D printers, some with a smaller build volume than the Ender 3 Pro, and some with a larger build volume. Now the Ender 3 Pro is an upgraded model compared to the Ender 3. Some of the changes include the power supply, a larger aluminum extrusion for the Y carriage to ride on, and a change in the way the electronics box is situated. See, on the Ender 3, the electronics box that contains the main board was oriented such that the cooling fan was on top, so bits of filament or other stuff could easily fall inside. For the Pro version, Creality flipped the box 180 degrees, so now the fan is on the bottom. And this also makes accessing the micro SD card slot easier because now it's up at the top of the box. And the Pro version also comes standard with the CMagnet removable build surface. Its frame is constructed of V-slot aluminum extrusions. There are 2020 extrusions, 2040 extrusions, and 4040 extrusions. And for those who aren't familiar with those terms, the numbers refer to the size of the cross-section of the aluminum. For example, a 2040 extrusion has a cross-section that's 20 millimeters by 40 millimeters, and the term V-slot refers to the V-shaped angle of the slots. According to the specifications on Creality's site, it has a print volume of 220 millimeters on the X, 220 on the Y, and 250 on the Z axis. However, the firmware axis limits are actually 235 millimeters on the X and the Y, and 260 millimeters on the Z axis. It uses a Bowden style extruder, which means that the extruder stepper motor doesn't ride with the nozzle, but instead feeds filament to it through a PTFE tube. It has a Meanwell brand power supply, which is an upgrade over the one used in the Ender 3. Now, Meanwell has been making power supplies since 1982, so they've been around for a while. It has a 128 by 64 graphical LCD, and it uses a rotary click knob to make menu selections. And like many 3D printers, it runs the Marlin 3D printer firmware. Now, unlike some 3D printer companies, Creality abides by the terms of Marlin's open source licensing, which means you can download the source code for the firmware that's installed in the printer, and if you need to, you can customize it or make changes to it, recompile it, and upload that back into the printer. It has a feature allowing it to resume a print after a power failure, which can be a lifesaver on a long print. And as I mentioned before, it has Creality's CMagnet removable build surface on a manually leveled bed. It includes a filament spool holder which mounts to the top of the printer's frame. It comes with a micro SD card and a USB card reader. The card contains a sample model, the assembly manual, and USB to serial drivers in case you want to print directly from your computer. There are Mac and Windows drivers included, and it contains 2 older Windows-only versions of the Cura slicing software, but no slicing software for Mac users. Fortunately, there are several free slicers you can download. It doesn't matter if you're using a Mac or a Windows PC. And it comes with all the tools that you need to put it together. Plus, it has a few spare parts. It has a spare nozzle, a replacement fitting for the Bowden tube, and a few other bits. And what about the price? How much more does it cost to go pro? Well, I just checked, and Amazon has the original Ender 3 for about $230, and the Ender 3 Pro for about $260. So with a price difference of only $30, it doesn't cost much more to get the Ender 3 Pro versus the Ender 3. Now, I'm in the United States, so I used Amazon as a source for two reasons. One, you'll get near instant gratification ordering from Amazon. If you have an Amazon Prime membership, you'll get free shipping and the printer usually arrives in 2 days. And two, Amazon has a remarkably generous return policy, so if you've got a problem with the printer in the first 30 days, you can generally just return it for a refund or exchange at no cost. With other sellers, you may have a hard time trying to return the printer or get an exchange, and you generally have to pay to ship the printer back. However, purchasing the printer from anywhere other than Creality's official online store will result in Creality refusing to honor their 1-year warranty and refusing to offer any technical support. This is despite the fact that Creality has a sales front on Amazon which promises Creality's warranty and lifetime tech support. So definitely do your own research on the prices and weigh the benefits of Amazon shipping and return policies versus the lack of post-sales support. And prices are changing all the time, so you may find a better price on this printer. So here are some of my observations about the Ender 3 Pro. As I mentioned earlier, the printer uses a Bowden system for the extruder, and Bowden systems have a PTFE tube between the extruder stepper motor and the nozzle. The motor pushes the filament through the tube down to the nozzle, and that tube is secured using couplers at each end. These are supposed to hold tightly onto the tube, preventing it from sliding back and forth as filament is pushed through it. Now on my printer, the coupler on the extruder side would not snugly hold the tube, and that caused a bit of inconsistent extrusion. A simple fix was to use a zip tie to keep the collar on the coupler snug. I could also have replaced the coupler with the one from the spare parts bag, but since the zip tie trick worked, I didn't see the need. Now, when you're loading filament on the Ender 3 Pro, I suggest cutting an angle on the tip of the filament to help guide it into the Bowden tube. Sometimes it may take a try or two to get the filament to enter the tube. The filament loading lever on the extruder is made of plastic. It's like that on my monoprice printers as well, but due to the positioning of the filament spool holder at the top of the frame, coupled with the fact that the filament enters the extruder from the side, the filament has to make a tight turn through the hole in the loading lever. And this causes the filament to rub against the top part of the hole, and over time, the filament can wear through the lever. And while we're talking about that loading lever, I also want to mention that on my printer, the screw at the lever's hinge point was a little bit too tight, and that prevented the idler from pressing the filament firmly against the drive gear. This resulted in a bit of under-extrusion, but again, it was a simple fix to loosen the screw slightly. Before I got this printer, I had only ever used direct drive printers, where the extruder stepper motor is mounted directly above the nozzle, and the filament path is straight down and in. I had heard that Bowden systems were much more susceptible to stringing, where you get those wispy spiderweb things on your prints, so I was afraid that I was going to have terrible print quality, but once I got a good profile going in Slicer Prusa edition, I've been able to get consistently good prints from this machine. For the first time on a 3D Benchy printed at a 0.2mm layer height, I was able to actually read the 3D Benchy nameplate on the back of the boat. I've printed this dragon by Turenkarn, which he has available on Thingiverse. My daughter refers to it as the dragon with abs, which is an accurate assessment. I printed it in CC3D's silk copper filament, which is just gorgeous to look at. And I know very few people see an XYZ calibration cube as a reason to get excited, but look at the print quality on this thing. Bowden systems also have a reputation for having trouble printing flexible materials. I printed this Calicat Insane Smart Black TPU. The print took about an hour. I turned my retraction off, which resulted in a bit of stringing between the tail and the body, and between the ears, but that was easy enough to trim away. This Sane Smart TPU has a Shore hardness rating of 95A. In the TPU world, that's actually a pretty stiff material. Softer materials may not work as well, but this Calicat is proof that the Ender 3 Pro can print some flexible materials. Now, a lot of Cartesian printers use smooth steel rods and linear bearings for the X, Y, and Z axes, but the Ender 3 Pro uses a set of wheels which precisely fit in the V-slots in the aluminum extrusions. The wheels have an angle matching that of the slots, which keeps them aligned and tracking straight and smooth. And the movement is quiet, too. And from a maintenance standpoint, you don't have to worry about lubricating linear bearings. Overall, the printer has a fairly compact footprint, and it doesn't take up much space on a desk. The frame is rigid and doesn't flex at all. And the design of the frame is such that all of the parts are pretty much self-squaring, so the X, Y, and Z axes are squarely aligned with one another, and that's a good thing. Now, while the mechanical aspect of the linear motion system is quiet, that is, the wheels that fit in the V-slots, the stepper motors and the cooling fans contribute greatly to the overall noise level of the printer. It isn't the loudest printer I own, but it's not the quietest either. It's kind of in the middle for noise levels. The hot end cooling fan is on whenever the printer is on. The parts cooling fan runs whenever commanded to do so by the G-code being printed, and the power supply fan runs whenever the power supply wants it to. It's thermally activated. So the noise level will vary throughout a print job. When it comes to adjusting the height of the bed, the knobs to accomplish this are freaking huge. Now that size makes them easy to turn, and it also makes it easy to make tiny adjustments in bed height. Now, although it's easy to adjust, getting that initial bed leveling done was difficult. With the Z-axis homed, the nozzle seemed to be a little bit too far from the bed, and the springs seemed to be near the limit of their travel. It took a lot of careful adjusting to get the bed close to the nozzle while still having tension on the springs. If the Z-axis limit switch could be set about 2 millimeters lower, or the bed springs were 2 millimeters taller and maybe a bit stronger, this wouldn't have been an issue. Now the Ender 3 Pro has the CMagnet flexible magnetic print surface pre-installed at the factory. The removable portion of the CMagnet system wants to snap into alignment with the base magnet, but the base magnet of the CMagnet system isn't properly aligned with the heated bed. As a result, the build surface is skewed relative to the bed and the rest of the printer. This doesn't affect the performance of the CMagnet sheet, but it does detract from the overall feeling of quality. Additionally, the sheet is a few millimeters larger than the build plate itself, so it overhangs on all sides by just a bit. Now, in practice, this makes it easier to remove the sheet when you're done with the print, because you can lift it from any edge that overhangs the bed, and you don't have to use that large tab at the front. When you print a model with a small footprint, it's easier to remove the CMagnet sheet than when you print a model with a large footprint. See, with a larger footprint, more of the magnetic surfaces are kept flat relative to one another, and that makes the magnets stick a lot better. So to avoid damage to the CMagnet sheet when you've printed a large footprint model, I recommend lifting up on the model itself while you're also lifting on the CMagnet sheet to get it separated from that base magnet. This will make it less likely to get a sharp bend in the sheet. A final note about the CMagnet sheet. Sometimes, but not always, the removable portion doesn't want to stick well to the base magnet, and this is usually due to not having the two properly aligned. My current strategy for reattaching the CMagnet sheet is to hold the sheet with the center curved toward the base magnet and feel out the natural alignment between the two. Then I let the sides down and everything is aligned. This helps to ensure that the center of the sheet has the best chance of sticking to the base magnet. The user interface is typical of Marlin firmware on a 128x64 LCD screen. At power on, the printer displays the Ender Dragon logo on the screen and then switches to the info screen. This is the screen the printer shows when you aren't directly interacting with it. On the display you can see the temperature settings and the current temp of both the nozzle and the bed. You can see the parts cooling fan speed, the X, Y, and Z position of the nozzle, and the print progress bar and a few other interesting bits of information. Pressing down on the knob takes you into the menu system where you can do things like preheat for PLA or ABS printing, home the axes, adjust printer settings, and select files from the microSD card to print. An important feature in the Marlin firmware is thermal runaway protection. Some printer manufacturers may use older versions of Marlin which didn't have this feature, or they may, for reasons completely unknown, disable the feature. I'm happy to report that on my printer, the version of Marlin installed by Creality on the Ender 3 Pro has thermal runaway protection enabled, and I've tested it just to make sure it works. I heated the nozzle to 200 degrees C, and then I unplugged the hot end thermistor from the main board. The firmware instantly displayed a min temp error on the LCD screen and cut power to the hot end, which is exactly what it's supposed to do, so good job, Creality. Earlier, I praised the print quality of the Ender 3 Pro. I do like it. I like it a lot. However, like many budget 3D printers, it can exhibit a printing artifact known as salmon skin. And you can easily see it on the wheelhouse of this Benchy. It's those diagonal lines there. Some people think that's the infill showing through, but no, it's salmon skin. And this is a side effect of the way some stepper motor drivers use microstepping to achieve tiny, precise movements. And it's such a common problem that a cheap, easy solution has been developed, the TLSmoother Board. I've done a couple of videos about those in the past. I haven't really gotten into how they work, I just consider them to be plug-and-play magic. But TLSmoother boards treat the symptom, not the cause. To treat the cause, you need better stepper motor drivers, but better stepper motor drivers cost more money, which is at odds with keeping the cost of a printer low. So to address this, Creality has released an upgrade to the main board used in the Ender 3 Pro at a cost of about $50 US. The board uses TMC 2208 stepper drivers, which should do two things for this printer. One, they'll reduce the appearance of that salmon skin effect on the surface of the prints, and two, they'll make the printer stepper motors run much more quietly. If you would like to see a video about installing and using that new mainboard, let me know in the comments. One of the heavily advertised features of this printer is its ability to resume a print after a power failure. Now I've tested this and found it to work, but I do want to make you aware of an issue that I discovered with it, which will cause the feature to fail. If you organize your G-code files into folders on the microSD card, for example, to keep all of the files for a project together, the printer will allow you to select a file that's inside a folder and it'll print the file. But the power loss resume feature will fail to work if you lose power while you're printing a file that's stored in a folder. When the printer has power again, it'll prompt you to resume printing, and naturally you'll select yes. The printer will heat the bed and then the nozzle, and then it'll home the X and Y axes. Then it'll move the nozzle back into the model, extrude a little bit of plastic in one spot without moving, and then just sit there with the hot nozzle on the model slowly melting the surrounding plastic. It's a less than ideal outcome for a flagship feature, so lesson learned, don't use folders on your microSD cards if you want to use the power loss resume feature. I want to talk a moment about the wiring on the printer. It's all point-to-point wiring. A ribbon cable from the electronics box simply goes straight over to the LCD. Output from the power supply goes straight over to the electronics box. Cables for the stepper motors for the X, Y, and Z axes, yep, those pretty much go straight to the electronics box with slack in them where necessary to allow an axis to move to its full extent. Now some of that's unavoidable given the design of i3 style printers overall. On the plus side, most of the ribbon cables are black, matching the color of the frame. And the cable bundles to the bed and the hot end are wrapped in this kind of black mesh, so everything kind of matches. The exception to this is the LCD cable, which is one of the common gray variety, so it kind of stands out a bit. Oh, and the LCD screen circuit board and wiring is 100% exposed at the back, which I don't think is a good idea. Oh, another note about wiring. The power supply's output cable connects to the electronics box's input cable by means of an XT60 connector. And there have been reports of issues with that connector overheating. Now, I've been printing with this for months and not had an issue with the connector getting warm or hot, even on 24-hour-long prints. But just because I haven't experienced an issue with it doesn't mean that the issue doesn't exist. If you have an Ender 3 Pro or intend to buy one, keep an eye on that connector. If it seems to be warming up or getting hot to the touch, stop using the printer. There are kits available to directly wire the power supply into the electronics box, and that'll eliminate that connector entirely. The direct wire cables connect to screw terminals on both the power supply and the main board side, so there's no soldering, just a bit of taking apart and putting back together. If you are comfortable soldering, you can simply cut the connector out of the cable and solder the cable back together again without the connector. And don't forget to put shrink wrap tubing on the wires before you solder them together. So with all that said, I think there are a few areas where Creality could improve things. First, to improve the bed leveling experience, Creality could redesign the Z in-stop mounting bracket to allow the Z in-stop to be adjusted a little lower than it currently does. Now thinking about it, that mounting bracket's plastic, so I could probably just trim it a little bit, adjust it, and re-level. But some people may not want to be cutting bits and pieces off of a new printer, since that sort of thing can be warranty voiding. Creality needs to document the limitations of the power loss resume feature, which doesn't work properly when you're printing files stored in folders on the microSD card. And Creality needs to improve their customer support experience. I contacted them via email before I had troubleshot the issue with the resume feature, and rather than try to help me with the problem, Creality's response was, "Did you contact the seller? Contact the seller. It's the correct and direct way. They will support you. Here is the only support if you buy from the official store." So here's my problem with that response. I received the printer as a Christmas gift. My wife bought it from Amazon. Creality sells on Amazon. Rather than asking for a serial number, an order number, or even pointing me to a troubleshooting guide, the initial response implied that contacting Creality for support on a Creality product was not correct. Amazon's not going to provide support for a printer they don't manufacture. They'll take it back within 30 days, but they're not going to support it. And I felt this was a poor customer service experience, but it's one that Creality could easily improve. The filament loading lever should be made of metal instead of plastic to improve the durability of the lever. And I think some improvements could be made to the cable routing. A simple set of clips which snap into the slots on the extrusions could hold many of the cables together for minimal cost. And the rear of the LCD screen should be covered to protect the circuit board and the wiring. Wow, we've covered a lot of ground. So what do I think of the printer overall? I like it. It's a good printer. The issues where I think the printer could use some from the factory improvements are mostly addressable after purchase. The Z in-stop mounting bracket can be clipped a little bit to allow it to be set lower. The bed springs can be replaced with stiffer ones, or you can print little end caps to go on the springs, effectively increasing their reach. Cable management clips designed for aluminum extrusions are more than likely available on Thingiverse, and metal filament loading levers for the extruder can be found on Amazon. Apart from the issue with the power loss resume feature and the lack of support that I received from Creality on that, I haven't had any major trouble at all with the printer. It works as expected, it's nice and compact, and I like the way it looks. Creality actually has several upgrades available for it, such as a BL Touch bed leveling sensor, different kinds of print surfaces, and that new main board with the quieter stepper motor drivers. So is this a printer that I would recommend to a first-time 3D printer user? Well, that depends on the person. If this is someone who's comfortable bolting parts together and plugging in cables, then yes, definitely. I mean, it's got a lot going for it. It's easy to assemble. It complies with the open source licensing for the Marlin firmware. The thermal safety features are enabled and working. It has the ability to resume a print after a power failure. The flexible magnetic print surface makes it easy to remove prints. It's got a good sized build volume, and you can print PLA, PETG, and some flexible materials. It's a very inexpensive printer for the quality of prints that you get from it, and there are support communities dedicated to the printer on Facebook and other sites. But I also understand that some people might want the kind of printer where they can just load filament and go and not have to worry about how all the parts go together. And for that type of person, I wouldn't recommend any some-assembly required 3D printer. That type of person's better served by a completely built and tested printer with support from the manufacturer. Now, that support might be via email, but more often it's via live chat or telephone. But that level of support comes at a cost, and that cost is always factored into the price of the printer, which is why a fully assembled printer with that level of support will always cost more than a box of parts with an instruction sheet. So as with any 3D printer, there are some good parts and some not so good parts, and the Ender 3 Pro is no exception. That said, in my opinion, it's a great printer for the price, and of the printers that I own, it's my second favorite. Do you own one, or are you thinking of getting one? Leave a comment and tell me what you like or don't like about your Ender 3 Pro, or ask me a question about mine. I'm happy to answer. Now, I plan to address some of the Ender 3 Pro's issues, as well as installing a few nice upgrades in coming videos, so be on the lookout for those. That's about all the time we've got for today's episode. Thank you for making it all the way to the end, and a big thanks to those of you who subscribe to the channel, because it means a lot to me, and it also helps the channel grow. If you haven't subscribed yet, I'd love it if you'd click that subscribe button down there, and those of you who like notifications can click the little bell to have YouTube whisper in your ear when I release new videos. Speaking of videos, I hope you found this one useful. If you did, please give it a thumbs up, and if not, give it a thumbs down, but either way, leave your thoughts in the comments. If you like the content I'm producing, please consider supporting the channel with a one-time micropayment. You could buy me a coffee, or leave a little something in the PayPal tip jar. There are links for both in the description. Well, now that I've shown you my Ender 3 Pro, I'm going to go print something cool on it. You do the same, and I'll see you next time.